Well, welcome to the Hexabuild web seminar titled Avoiding IPv6 Deployment Disasters. Today, we're going to share with you some of the typical ways organizations fail when they're attempting IPv6 and planning and going through their deployment. Then we'll discuss best practices, methods to stay on track, gain steam, and avoid getting derailed. So we're going to be covering, how to avoid the typical adoption mistakes that we see organizations make, gaining executive leadership, organizational buy-in, building that business case, to justify the IPv6 project and program, how to capitalize on late mover advantage. We're going to talk about IPv6 addressing strategy, best practices, what not to do. We're going to talk about how you should prioritize IPv6 training early in the project lifecycle. We're going to talk about, successfully assessing vendors' products and services for IPv6 support, and talk about this future, IPv6 only deployment scenario. So let's go ahead and get started. I'll introduce the Hexabuild team. Hexabuild, we're an IPv6 consulting and training company with over 60 years of IPv6 experience, even though each of us have been working on IPv6 for 10 to 15 years. We've provided, consulting and training services to organizations of all sizes. And our philosophy is really to help you and your teams perform the IPv6 deployments yourself. We want to be an enabler. We want to be your support team, your phone a friend, and guide you, teach you, and advise you based on our decades of IPv6 experience. And that's what we're doing today here, is giving you some guidance. So first on our Hexabuild team, Ed Horley. Ed has been involved in the IPv6 community for decades. He's created a lot of content, a lot of training classes. He's authored the APRESS book, Practical IPv6 for Windows Administrators. He's been involved in the IPv6 task forces here in North America and specifically in California. He's a colleague of ours on the Infoblox IPv6 Center of Excellence, major contributor and leader of the IPv6 Buzz podcast, frequent contributor to other podcasts on packet pushers, has an IPv6 class on Pluralsight, and just extensive amount of IPv6 experience. Tom Coffeen, also with us today, author of IPv6 Address Planning, has many years of IPv6 deployment experience for service providers and previously with Infoblox. He's done other work on teaching IPv6 through O'Reilly, also a contributor to Packet Pushers podcasts and the IPv6 Buzz podcast. Has created videos, been involved in the IPv6 task force, given numerous presentations, and has just abundant amount of IPv6 address planning knowledge. So he'll be sharing that with us today. Myself, I'm Scott Hogue. I'm author of the Cisco Press book, IPv6 Security. I've been involved in the IPv6 task forces as well. I contribute to the IPv6 Buzz podcast, the Infoblox IPv6 Center of Excellence. I've written for Network World a number of years, many articles on IPv6, contributed a class for A Cloud Guru. And so we're here today to really talk about, the topic, how to avoid IPv6 adoption mistakes. But it's really two sides of the same coin, avoiding the mistakes, but then really trying to adhere to the leading or best practices that will result in a successful IPv6 deployment, which leads to rainbows, puppy dogs, ice cream. And so with that, you will be bouncing back between both, how to avoid the mistakes and how to adhere to the best practices. So that's a lot of what we're going to cover today. At Hexabuild, we have a IPv6 deployment lifecycle type methodology. And it really starts with helping organizations build that adoption plan, getting organized, using a disciplined approach for IPv6 deployment, and building that stable foundation at the beginning to start off on the right foot. Early in that process will be assessment, figuring out where you and your organization stand, looking at making sure all of the things at your disposal, the software, the products, the services that you use from various vendors are v6 capable and that there's no obstacles in your way. Training and education early in the process to help you understand the protocol, and therefore all the other subsequent conversations you're going to have about IPv6 are that much more effective and productive. We really feel strongly that having that good architecture, the design, the address plan, and all of the other technical plans that go into that architecture form a stable foundation. Once you have an idea of where you're headed, then you can start to do some configurations, some proof of concept, some testing, getting your configurations ready for deployment. And really, this is where Hexabuild team likes to step out of the way a little bit and be an enabler for you and your team to proceed with deployment and operations. We feel that your organization is going to need to be responsible for the long-term operation of IPv6. It's going to be in production use for many years, and so we need to enable you to do those parts of the steps. But we want to be involved early to make sure you get off on the right track. So one of the first things here, Ed and Tom, that we want to talk about is, making the case for IPv6. Ed and Tom, what are some of your thoughts here?
Get myself off mute first. Yeah, I think making the case is always an interesting discussion, because there are a lot of situations where executive team really don't understand some of the underlying components about what's happening with something like an IPv6 adoption, why you need to do it, how long is it going to take, what sort of budget's involved. And I think those sets of conversations are, for many people, difficult to have. And it's important to have a strategy around how to go about doing that and to be able to articulate what exactly that's going to be. So I think those are really the things that we see on an ongoing basis as sort of the struggles for many organizations to do exactly that. It's like, what impact is this going to have? Is there a business advantage of doing this? And I think that's what we've all sort of seen over and over again, right? In terms of walking in for organizations that may have stalled on their IPv6 adoption. They've gotten something started as a skunkworks project, but they can't get their management team to decide to roll it out to the rest of the organization, or to even use it as a strategic tool in their tool belt to make something different happen.
That's true. Oftentimes, right, Tom, we see there's, a few people, one or two kind of champions of IPv6 in an organization, and they have hard time garnering consensus and getting everyone on board. And so sometimes it does start out as a grassroots type project that is unfunded, not legitimized, doesn't show up anywhere on the docket of, the annual IT projects. So it tends to get avoided, or management can start to schedule other priorities on top of it, and then you just never make progress on it. We've created a video here, and we've got several links in our slides for different things that we've created. And one, we recorded a video on business case examples. But yeah, Tom, what are some of the other considerations here?
Yeah, I would bet that there are probably some folks on the call here today that are in that situation where within their organization, they've recognized that IPv6 is a fundamental technology that's going to enhance accessibility to a lot of sort of the emerging networking technology that we're going to be relying on, related to cloud, related to IoT. And unfortunately, management isn't always willing to recognize something as fundamental as a networking protocol, which seems so sort of basic on the surface, as something that needs to be critically resourced and funded. And so oftentimes those resources within organizations, the IT folks are left trying to do what they can to deploy IPv6 and effectively manage it, because it's already there, right? It's already in the network. It's already running on hosts. It's already enabled by default and preferred by default. And so, even if it's something where the organization hasn't really paid much attention to it, it's still something that requires management. So yeah, it is one of the things that we try to help organizations with is building that case to management, so it doesn't have to be so much of a bottom-up effort, which of course is always necessary, but you can get the critical support that you need from management, get their buy-in, make it more of a top-down and organized cross-functional initiative that it needs to be successful. So you can really take advantage of IPv6 in the way that it's going to enable key technologies as we move into the networking future.
Mm-hmm. Yeah, you mentioned something, it's already included in many products and services by default. It's already in all of our operating systems that we use. So as Ed's mentioned before, the late mover advantage, you've waited. So you're not in the early adoption phase. You're really in more of the majority phase here where you've waited to deploy IPv6. It's in many of the things you have. It's just a matter of turning it on, right?
Yeah, that's absolutely. Go ahead, sir. Sorry, Ed, go ahead.
No, well, yeah, it's completely correct. I mean, I think the other thing that many people are starting to realize, which is another turning point for orgs, and we've seen this now come up more and more, is there's mandates around IPv6, right, for the U.S. government, for on the finance side with Bank of China. So there's a lot of other things that might influence the sets of decisions that maybe not everyone is aware of. And so I think those are some of the things we've learned in the field from our experience of working with customers. There's state mandates, there's federal mandates, there's other international entities that are also putting mandates around V6. And then there are also frameworks that are available out there from a business case perspective. There's technology frameworks that are V6 only. And so if you're not aware of those and your management team isn't aware of those, they have no idea why they need to adopt V6. So I think those are really good business use cases about doing those. So if you have those are useful things to sort of piggyback on.
Yeah, there's mandates, for countries or different large scale organizations, governments to adopt IPv6 and create dual protocol infrastructure, and those tend to be fairly soon. And then there's even mandates to turn off IPv4. And if you're doing business with a government, you're operating in those geographies, that could impact you down the road in the 2025, 2030 timeframe.
Yeah, absolutely. So I think those are the things that are sort of the draw there in terms of at least the business case side.
Yeah, and as you make the business case, you want to tie characteristics of IPv6 to your organization's mission and goals and what you do to help and provide services to others. Whether it's dealing with address scarcity, mergers and acquisitions. We have a white paper on that that's available. Whether you're deploying something new like IoT or cloud, IPv6 could be faster. So if you have a web site, a mobile app, you want it to be faster for all people, there are all systems that might be connecting. Yeah. You definitely want it to be a dual protocol. So building that business case helps garner management acceptance and gets the project started. The next thing you'll do is early in the process, you'll build that plan, that IPv6 plan, and you got to write this down. It just can't just be something that you as the grassroots project that you just have in your head and you aren't really thinking about a disciplined approach. But you start with a high-level adoption plan, and then that's supported by many other plans that contain more of the technical details and the next level of abstraction down. How to build a team, what's your training plan, what's your addressing plan. Addressing and routing go hand in hand. How are we going to handle DNS, security? How are we going to manage it? So you're going to document these steps along the way. And so Ed and Tom, what are some of the other considerations here? How do organizations fail at this step?
Well, I think this is the great failure of most deployments. You don't have the right team involved. You don't have all the right members involved, and you don't understand the scope of the project. And I think this is where the vast majority of organizations that we've interacted with, this is where things fall apart. If they get past the business portion, or even if they haven't involved that part and they're just starting to figure out the adoption plan part, and they haven't done any documentation, maybe they've turned up a portion of their network just because of the networking team and they can get away with doing it, right? Mm-hmm. And they don't have a real plan in place. And so they don't understand the business advantage, but then in addition, they don't understand what impact it's going to have on the rest of the organization and what strategic advantage it's going to have. And they might have the routing plan put together. We probably walked into a bunch of organizations. They've actually got a reasonable routing plan. Maybe not a full address plan, but they got a reasonable routing plan that's working because they had to get something operating. Mm-hmm. But they haven't tied in the ops team, the security team, the port help desk folks. So the moment they turn it on for client access, it just things go horribly wrong. And I think these are the things that are mistakes that we've seen sort of time and time again where that's gone on. And I don't think I think they're very easy to avoid, assuming you want to take the step. But if this step isn't a formalized process in what you're doing, then you're going to make these mistakes. And it's just, we've seen it over and over. And we actually have a show that talks about, on the IPv6 Buzz, talking about all the sort of additional teams. And you did this show with Dan York talking about, all the app services and everything else that needs to sort of be involved around making sure that V6 is going to work well in your environment. So it's a really good show to listen to if folks are interested in checking that one out.
Yeah, the only thing I would add to that is IT is so siloed, and the protocol, IPv6 has sort of a built-in booby trap that exposes that in organizations related to the fact that you're going to have to manage auto addressing at some point. But who normally in the IT team manages IP addressing, manages, the DHCP as the case may be. Oftentimes that falls to the server team or the desktop team, somebody that's in one silo of the organization, not related to network and routing. And so, right there, you may have IPv6 enabled in the core, and of course that's pretty easy to do. If all the routing protocols support IPv6 very effectively and in multi-topology mode, so your network can be super stable. But then when it comes, as Ed just pointed out, when it comes to actually turning on IPv6 to the desktop, who's responsible for, say, if making the decision, first of all, which auto addressing direction you're going to use, whether it's going to be Slack or in most cases DHCP6, and then making sure that everything's set correctly on the network interfaces that are facing the hosts and servers, that the right auto addressing configuration is there.
Mm-hmm. It's a coordinated effort for sure. But and Tom, you and I both know, and Scott too, that the whole goal is to manually assign every single address on every host in your 20,000 node network. So.
Oh, yeah. That's how you know it doesn't change. Yeah. You always know where everything is. Yeah. But
it's job security. It's job security.
Yeah.
And please, for those who are maybe sarcasm challenged on the call, we're actually just joking. We really don't want you to manually assign 20,000 addresses.
Yeah, but getting the team together is important. It can't just be in the realm of the network team. And I've seen that in a large organization where it was within the realm of the network team. It's a federal organization. They deployed OSPF version 3. Beautiful OSPF v3 design, addressing, all laid out, but it wasn't connected to the internet. It didn't advertise the prefix to the internet using BGP, and there also wasn't any IPv6 address on any downstream layer 3 interface to be a first hop, so there were no routing advertisements sent down to any access devices. So really the only IPv6 packets on this network were OSPF v3 hello packets. So the network team, check, but no security team, no transition team, no training, no end user support, no desktop involvement, no applications were using it. So a fail, I give them a fail because they failed to, get all the groups involved.
It's the most awesome CCIE routing lab ever.
Yeah, exactly.
That's right.
Yep. Redistribute everything into everything. Yep. I want all the routes. Yeah. Yeah, good point. So addressing, in our methodology, in creating that addressing plan comes early. It's on the critical path. You can't do anything until you figure out what you're going to do with addressing. And it'd be great if we had someone on the call today who knew a lot about addressing. And
I don't know who that is.
Oh, gosh.
Shucks, guys, you're making me blush.
Well, just for those that don't know, Tom wrote a book about address planning for IPv6. So
yeah, and to give the context for that, I mean, it was the scenario where I was in the organization where IPv6 was like, hey, go figure out how to turn this on and run it and get it in the network. And I'm like, me? Okay, let me see what's available to figure out what to do with these 3 blocks of IPv6 addresses /32s that obviously have an enormous amount of IP space. I had no idea what to do with it. There was, at the time, it was like 2008 or 2009. There was some guidance from IATF RFCs. There was a little bit of operational experience, but But it really was just a sort of panic moment where it's like, I've got all this space and I just don't know where to start in terms of carving it up. And of course, the first thing I start doing is thinking about it in terms of IPv4. And that's why I ended up having to redo my first address plan several times to get to the point where it actually made some operational sense. And so that was sort of the impetus for putting the book together so that other folks wouldn't sort of wander through the same wilderness that I had to wander through. But it is a critical piece, and there's really a chicken and egg problem here because you need to have enough of a sense of the size of the network and the scope of the addressing that you're able to ask for the right amount of space from the service provider, but in most cases, you're going to be actually getting space directly from the regional internet registry in the region that you're in, space that's actually routable through any provider. Space that your organization is going to use probably for the duration of its existence. And you need to make sure you get enough of that space. And that sounds a little weird because, obviously a /64 contains the entire internet within it. One subnet interface contains, vastly more addressing than the entire internet itself of IPv4. So the chicken and egg problem is how do you scope how much address space to ask for so you can start to do your plan. But then, of course, you have to go back and actually get really specific and detailed about what that plan is going to look like in terms of where the addresses and prefixes are actually deployed. So it is a really critical effort. You do have a late adopter advantage here, and what we've seen is that a lot of enterprises and your company may fall into this category if they took initiative and got an IPv6 address allocation early, they may have not gotten a large enough address allocation to really take advantage of the space that's available on IPv6 and really lay it out so that it's operationally efficient and something that can scale and grow with the network for the next 10, 20, 30 years. So you may be in a scenario where if you already got the block of address space from the rear, it may not be large enough. You may actually have to go back to the rear and get a larger block. If you haven't gotten the space, then you can avoid that mistake right at the beginning and make sure that you're getting a large enough block to allocate with.
Yeah, early on, RARs were pretty stingy. They didn't want to repeat the same mistakes of IPv4 by giving out too much. Now they're a lot more relaxed and they want to give you the address space you need, but you need to have that long-term vision of where my network's going to be many years, decades in the future, and build then that growth to get the right allocation right from the start.
Yeah, absolutely. And I think our experience has been, because hopefully folks are interested in hearing what our experiences are, but our experience has been, we've gone back several times for a bunch of different organizations and said, this isn't enough address space given where you're at and what we're planning. And we've run into this time and time again with a bunch of different customers. And I think they often miss some of the foresight of thinking into the future about what they're going to need. Things around cloud and bring your own address space to cloud, things around IoT and planning for IoT and sensor networks. And there's just a lot of categories that maybe they weren't considering before because it wasn't part of the initial request for IPv4, because you would be like, I would never ask for public IPv4 space to run my IoT stuff. I would do RFC 1918. Right? And I would never expose that stuff out. Well, you have to think very differently. So that's that difference between V4 and V6 thinking that we had mentioned earlier. And I think there's also that common mistake that we see over and over again, that their addressing plan is coupled or decoupled from their public address space, because that's a V4 way of thinking too, right? We run an RFC 1918 plan on the inside portion of our network, and then we run a totally different plan for the public side. Right? And often those are shared resources in the V4 space. And in V6, we have to turn all that off. We have to think just with our global unicast. We shouldn't be using ULA. Tom has some great articles about what not to do with ULA. And for those that don't know, unique local addresses are a portion or a subset of V6 address space that is designed for folks to be able to utilize for specialty use cases, right? Where you need to have something fully isolated outside of your regular global routable public V6 address space. And it's reserved for special use cases. And a lot of people think it's the same as RFC 1918, but it really isn't. So don't use it that way. That's our bit of advice, right? We've seen several organizations that have made mistakes there, and just don't do that with your addressing plan. That's our first recommendation.
Yeah, I mentioned, Ed developed this method of using IPv6 as part of a mergers and acquisition strategy. So if you went and got enough address space for your organization, not thinking that you might also acquire other companies, and you might use IPv6 as the globally unique address space to tie the organizations together, rather than having them constantly readdressing their IPv4 address when sub-companies get acquired. And you have to then figure out how to avoid overlaps. Use IPv6 as the non-overlapping universal address space for native communication between all the companies that come together and are acquired or merged. So Ed created this concept. But if you just got the amount for your company, not thinking that that was your long-term strategy as a business, you would have missed that and not had enough.
Yep.
Yeah. I've also seen federal organizations that got allocated a /32, for example, because they're large. And then they were like, oh my gosh, 32, and I got to divide this up into 64s. I have 4 point so many billion /64s. Okay. And then they force other levels of hierarchy that are artificial or contrived. And they didn't need to make it overly complex, but you have so much space, you tend to want to create this grand unification theory of address planning, and you overthink it, right, Tom? Some organizations can do that too.
Yeah, you can really paint yourself into a corner with that. And a lot of that is really about the fact that we have this incredibly powerful tool that we've been using for years for IPv4 to conserve host addresses, and that tool is variable length subnet masking. And we've gotten so much into the habit of using individual bits to carve out prefixes of the right size so that we have enough host addressing. That's our reflex, and we want to bring it to the IPv6 address planning game. And as you point out, I mean, with the amount of space that you have, we're really returning to a very early stage of the internet where we had actual classful addressing, and the idea was, it doesn't matter what size the network is in terms of host addresses. I'm really thinking about it as a functional entity or a geographical entity, and I'm assigning a block of prefixes to it that's the same for the same type of functional or geographical entity. And so that you get really just this amazing amount of consistency. And if I correlate that to the nibble boundary and the address plan, that means that I'm always looking at a prefix that's immediately recognizable for whatever that functional entity is or geographical entity. And so there's just incredible power in that, but you have to trust that you have enough address space to be able to really take advantage of that. And too much like overthinking about it. The other catastrophe, I mean, if you really want to, you can almost always rework your address plan. It's easier to do from the bottom up than from the top down. But the real catastrophe is when organizations try to map their IPv4 address plan into their IPv6 one. I don't see that.
I've never seen that.
Well, it doesn't happen as much as it did in the early days. And I totally understand the impulse, because I started to go down that mental path myself when I first got, a block of IPv6 addresses. Like, how do I make this relevant to what I'm doing now? And the answer is you make it relevant by, as Ed points out, it's totally greenfield. You got to think about what the network's going to look like in 10, 15, 20, 30 years. And part of that is really just, using your imagination to trust that you have a big enough block that you're going to be able to support all those applications and networking components going forward.
Yeah, for just a moment, Tom, I thought you were going to say the powerful tool that we have for doing IP addressing is Microsoft Excel. I thought you were going to say, and then I often joke, as people ask us, right, do I need an IPAM, IP address management system for IPv6? And I often jokingly say, no, you need one for IPv4. And the crazy shell game of readdressing and the insanity of /27s and /28s and 29s that you have today, how can you keep that in your brain or in Excel? It might be a good way to start your IPv6 address, planning, just to think, well, do I have enough? But you really do need an IPAM system for IPv6, right? Because you are dealing with hexadecimals and
yeah, it's a safety net. And of course, dealing with individual host addresses, with the number of characters involved and transcribing addresses, if you have to copy an address, from the command line to another document, et cetera. I mean, we're really used to doing it with IPv4, and of course, we still screw it up with IPv4. So it just the opportunity for error is much greater in IPv6, and so yeah, an IPAM can really help in that regard. The flip side of that is that an IPAM also sort of, if you're really into your IPAM with IPv4 and you're trying to do the same thing with IPv6, it may not be the best tool upfront to use for your IPv6 address plan, it's going to be the best tool to use for tracking your IPv6 deployment as you go forward. But you definitely don't want to try to take what you've done in IPAM and IPv4 and bring it into IPv6. But having said that, you make a good point. It's like many enterprises are unable to generate an accurate IPv4 report of where the addresses are actually being used. And then, of course, oftentimes it's like, well, we have an IPAM tool, but then I actually have the secret spreadsheet over here where I have the real allocations that are tracked.
Yeah, you just memorize it. And actually,
that's right.
If you did aim for simplicity and flexibility, and you focused on that nibble boundary, you can memorize IPv6 addresses just like you memorize IPv4 addresses, and it can, in some ways, be simpler and have ease of management built into it. So. Yeah,
absolutely. It can be quite. Yeah, that's a great point.
Yeah, cool. Any other thoughts about where people go wrong with addressing?
I think we've covered it. I'm looking forward to any questions that folks might have when we get to the end of the presentation.
Okay, yeah. For any of you online, put your questions into chat, and we'll have a Q&A session here at the end. So, and then you'll have our contact information after the presentation if something occurs to you later today. Okay, so we talked a little bit about training and how that needs to be kind of early in the process and not to delay it till later in the project. I had an IPv6 engagement with an enterprise where they didn't want to do training. They're like, nah, we think we got it. And then we started to do design and actually jumped right into proof of concept configuration. They'd ask me a question and I'd be like, well, there's a slide from my presentation, my training deck that answers your question. And then I'd show them that. Okay. Then they'd ask another question. I'd be like, yeah, from day 2 of my training class, I covered this, and I show them slides. It was like, okay, well, you're getting it, but you're getting it piecemeal, not holistically.
They don't have the big picture. I think that's a huge frustration for all three of us because we do this on a regular basis, right? Is sitting in the room and wanting to do a design session with a team, right? And be like, let's bring you along for how to make good decisions. And they're like, I don't understand why you're making that decision, right? Like, why are you recommending that to us? And it's because they lack that core set of comprehension around IPv6. Like, why are you making that set of recommendations? It doesn't make any sense to us. It doesn't match what we do in V4. It doesn't have any corollary to V4. How do I figure out is that a good recommendation or not? And so getting people in that training early, and Scott, you do a great job of this because we basically have the equivalent of a boot camp that provides people that, especially in the network team and the architecture team that really needs to make those key sets of decisions. Those folks need to be able to walk into the room and have a good discussion about V6, even if they only learned it last week, right? That's okay. They can make good decisions based off of that. But if you don't have that training until later in the project, you've made all the wrong decisions early on because you just don't know what you don't know, right? It's one of those weird things. I think that happens there.
Yeah, there's getting to be more and more good resources, on the internet. Books like Rick Graziani's book from Cisco Press on IPv6 fundamentals. That's a good book to learn about IPv6 basics. You do need to train a wide variety, just like you build your team out of an interdisciplinary, multifunctional team across those different IT silos. You need to train them each for their particular role and responsibility, and you need to train them just in time. You don't need to train the app developers today, but maybe just before you get some V6 network connectivity established and you're getting ready, and so your high-level plan will help guide you about when to train certain teams.
Yeah, I can't agree with you more because I've seen a lot of organizations, they do that maybe they decide they want to do a big bulk of training up in the beginning, and then you have help desk and systems folks, but the network team hasn't even started to deploy anything, and it's going to be 6 months down the road before they can even touch anything. They're going to forget everything that you taught them in that class by the time it comes to actually do something. I think we've all seen that. So you need to have training that's appropriate at the right time for when they're going to get it. And I think a proof of concept lab also allows you to sort of time that a little bit and maybe get a little bit ahead of it before they necessarily get involved with anything in your production or corporate network or wherever you're actually deploying V6.
Yeah, some government organizations maybe got trained a long time ago because there was a mandate and okay, we better learn about IPv6. But then it wasn't followed up with any action and they lost that knowledge. And so
Yeah.
you want to train, and hopefully, well, we've also seen this where organizations get trained and then that helps inject some some stimulants into the IPv6 project, get people enthusiastic about it, reduce the fear and anxiety about those large addresses, and then people realize, oh, I got this. This isn't that bad. Once they get trained, then they're on the side of being knowledgeable, and they're like, yeah, this is realistic. This is feasible. I can do this. I'm comfortable.
Not that bad. What are you talking about? It should be that. This is awesome.
Yeah, and then they get energized. They get excited about it, and then having the project then have them put that training into action helps just reinforce the training.
Yeah, I can't agree more. I mean, it's one of those funny things where training is, everyone sort of groans. I have to go through training. What's funny enough is for the three of us, I think that's probably the most exciting part of what we get to do is to share knowledge around V6. So we get all excited about it. But I'm sure folks who are going through like, this is something I have to learn again. Something yet again. I took this class back in 2010. What could have possibly changed? And believe it or not, actually, a reasonable amount has changed.
Yeah.
So it's important to keep up to date around it. And I think using things day to day, like we're so comfortable with IPv4 that we just think, how hard could it be to transition to V6? I'll pick it up when I need to know it. Mm-hmm. Well, and that time I think is really here for many organizations. It's starting to happen more and more. And so I think formalizing it and going out and getting that training is going to be important for folks. Mm-hmm. And we've seen a lot of organizations that have made this mistake and just crossing their fingers that their security team is going to come along and figure this out. That doesn't happen. They need training just like everyone else. Your help desk needs training. Your network team needs training. Your systems and apps teams folks need training. Like all of those different silos within your organization. Sometimes even, believe it or not, folks that are outside your organization may need it because they're a partner organization and they need to rely on it. And this is a good use case, talking back to the business use case that we talked about earlier, where the Bank of China actually sent out mandates for many of the banking institutions that are working with them about their interactions and requirements around V6 to work with them. And I think this is a great example of a bigger entity forcing downstream entities to suddenly have to figure out how to do V6, even though it's not within the realm of their quote unquote network that they own. They're putting it in as a mandate. And so your team has to catch up to speed about what that mandate might actually have as impact within your org.
Yeah, or you're a university and the National Science Foundation says in order to get certain kinds of grants, you need a V6 enabled network. And so that prioritizes you to V6 enable some of your scientific DMZs and things like that. So yeah, so there can be a mandate that causes downstream IPv6 projects. Yep. And Ed, you've talked about the importance of training help desk teams because you have IPv6 running in all of these devices today. And if your users are remote, they're working virtually, they could actually be using IPv6 and maybe not even be aware of it.
Yeah.
There's V6 enabled sites, there's V6 enabled endpoints, there could be V6 enabled wireless service provider or home broadband internet connections. And then if they run into a problem, they call the help desk and it's a V6 problem and the help desk is like, what? What is this?
What? Let's turn this thing off. All right. It's a great point. I mean, I think the other part of that is because we're so dual stacked today, they need to understand the difference between the two, how to troubleshoot across the two. And that's a whole different skill set that maybe even the network team is involved with because they don't deal as much with the host operating systems and how that behavior is in there. And then you've written and talked about some great use cases around VPN breakout. So for all of us that are working from home, which is pretty common now, right? That VPN breakout can have impacts in your corporate organization and what happens there. And that's that knowledge about IPv6. That's that knowledge about understanding what's happening with two sets of protocols that are running and how that impacts your organization. And if you don't understand that, you can have other impacts within your organization around enforcement, compliance, and a bunch of other things. And it's just simply, it's a gap because you just don't know any IPv6. So you don't understand what's going on with that, individuals sitting at home with Comcast that's dual stacked and has V6 available to them, but you're not tunneling any V6 back to your corporate network and they're just going straight out to the, the public V6 internet because guess what? That's the preferred way to do it. So I think that's that knowledge gap that's really important.
Yeah, great points. Okay. The next thing we wanted to talk about was assessing vendors. Now, in some cases, you might have waited, and now you do have quite a bit of V6 capability. But there can also be gaps where maybe the vendor hasn't given you all of the functional parity between what they do for V4 and what they do for V6. And so figuring it out can be difficult, right, guys?
Yeah, I think the vendor assessment side is the great wandering in the desert right now. It's hard to figure out exactly where things line up because none of the documentation is focused around sort of where things fit within a V6 framework, and that's fine. They don't write documentation based around V4 framework either, right? So that's not unexpected. I think what's unexpected is that there's not a clear, easy way to figure out exactly where vendors have feature sets of support. And if you don't have the knowledge, you don't know what to ask for in terms of feature sets within a platform either. And so I
think there's a really good example of this, Ed, just to interrupt because we've talked about this before. And when you talk about the documentation being lacking, what we're really missing is the V6 operational cases in the documentation, right? We've got plenty of that for IPv4 because it's been around for so long. And so that's actually a nice little trick you can use. Does your vendor documentation include IPv6? Does it include examples of network operations, configurations or deployment where IPv6 is used in the example? Those are conspicuously absent in the case of many vendors where, obviously there just isn't a lot of operational experience with the protocol, and they may be supporting it at the protocol level. But in terms of how that's filtered down to what they're doing and the documentation operationally, it's just not quite there.
Mm-hmm. Yeah. It's sometimes tough to get to the right person in the vendor's, development team that can answer the question sometimes. Sometimes the data sheet just says, IPv6, checkbox, may not even say RFC 8200. But you're wondering, what do you do with IPv6? What? And so you ask your account manager, God forbid, you ask your sales engineer, but you really need to get to someone pretty knowledgeable in the organization, and that's tricky to get to the right person, right?
Yeah, often that's actually a product manager or an owner of a product. It's very unlikely you'll get to the actual engineers or developers who are building on the product, but. I think the other side is there's maturity among different vendors and understanding where they fit within the ecosystem is important. That's some of the advantage you get out of working with us is that we have a pretty good roadmap and understanding about where many of these companies are at, where they have, maybe some slightly different than RFC standard configurations for some of the components around V6, some that are strictly enforced, some that are moderately enforced, some that are very loosely coupled, right?
Yeah, that's right.
And that's the hard part, and that's where proof of concept lab really comes in. If you're going to evaluate your vendors, besides the assessments that folks like ourselves can provide around sort of product knowledge and sort of we've seen this in the field and we understand this because we've been around enough gear, you have to get your own lab up and going and testing. And to really understand how your product and the suite of products that you use in your environment are going to interact and perform in V6. Yeah. I can't tell you how many times, they're just like, it says V6 on the checklist. We're good to go. Let's roll. And then we get into the deployment and we're like, no, none of this is working the way you think it is. And you have to step back and then you're back in the lab again.
Yeah. You find some little caveat when you're kicking the tires in the lab. You realize, hang on a second, that's available. That config is in the GUI or the web UI. I got to go into this esoteric CLI to do this other thing. Then I come back to the web UI and do this, finish up the config.
Right.
That wasn't it.
It's ordered. Right. It's order dependent too. Mm-hmm. So if you don't do it in the CLI first, but you try and do it in the GUI and and try and figure out how to clean up. And then different versions of code over time have different attributes or behaviors that are by default. Mm-hmm. And then, you can have a lot of fun in the operating system side because depending on when the operating system was released and what patch releases are there, you can have totally different RFC conformance. So those are the sorts of the things that become more of a challenge as you're going through it. I wouldn't say people make mistakes around this. I just think it's it's like I said, it's wandering in the desert. You don't really know until you stumble across that thing, and hopefully you hit the oasis and you're all good. But I think there's definitely a strategy to try and get across the desert, but I don't think you're going to necessarily know every single thing that's happening there, and that's where a proof of concept lab really helps you.
Yeah,
I like your wandering in the desert analogy is really good. I think based on past experience, I think I prefer the wandering through the minefield analogy. But just to characterize that, one of the things is the late adopter advantage we talked about earlier. That a lot of vendors have actually made tremendous progress in supporting v6 in the way it needs to be supported operationally, so that it can be deployed effectively. But it's really, as you point out, without a proof of concept lab for your particular deployment, you may not know who those vendors are, or you may be getting one message from the vendor while the actual gear support, the level of support within the gear is very different. One of the things that I always recommend that our customers do is to see the roadmap, the feature roadmap for whatever the product set is, and make sure that v6 is included as part of that, because it can be a real warning sign if you at this late stage of the game, 2020, with a tremendous v6 support in a lot of platforms. If you're looking at the vendor roadmap and they're sketchy on the v6 support going forward, it's always a big red flag and a warning sign, or a mine that you might be stepping on as you're wandering through the minefield.
Yeah, absolutely. Okay, so let's keep going. And if you have, so we want to make sure we have time for questions. So put your questions in the chat as we go. And then we don't want people to discount how they may be actually able to do IPv6 only in certain parts of their architecture. That may be somewhat realistic these days, to skip the dual protocol step, reduce administrative burden of running two protocols, just run v6 only. That could be a late mover advantage technique too.
Yeah, I think it's one of those things where you have to remember with dual stack, and let's talk about this really quickly because I think this is just the important point. In dual stack, you still need to use v4. So if you're running out of v4, running dual stack doesn't solve any issues for you. Mm-hmm. So you may realistically run portions of your network as v6 only to help in that. Maybe have a transition portion of what you can provide around v6 only for those v4 resources. But thinking about that for IoT projects, maybe for sensor networks, maybe for portions of your data center or cloud infrastructure, could actually solve this. And there's demonstrated, v6 only, situations out there that we could talk about, and some of those maybe we talk about data center, because these are sort of well known and published, and we've had these on the task force presentations that we've had in the past around the North American and Rocky Mountain task forces, right? For Facebook presenting around their v6 only data center, because they have a very large deployment of v6 only data center, and then LinkedIn doing the same thing. They just didn't want to be constrained around trying to think about v4, so they actually make it as v4 as a service coming in and out of the data center, right? They basically put server load balancers that translate v4 to v6, and then if they need to drop v4 on any given host, they can actually tunnel it all the way to the end host over v6. So that's how they solve or move around that. And then we have a bunch of service providers that are v6 only, right? So T-Mobile being the most famous here in the US, but in India, Reliance Jio. So there's a lot of options around sort of v6 only that sort of demonstrate that you can do this at scale, that it's real world today, and that it might be a consideration depending on how your organization's built to go ahead and consider doing that.
Yeah, and we've had many of those on as those folks on as guests on our Packet Pushers IPv6 Buzz podcast. So if you're interested, you can listen to those shows. So yeah, at the very least, make sure IPv6 is part of every net new project. Like, let's say you're deploying a Wi-Fi 6 deployment. You're going to be upgrading WAPs and controllers and all kinds of infrastructure. Might as well bake IPv6 into that right from the start, right? Rather than have to treat IPv6 as a secondary project. Start off with it at least as a consideration. Okay. Yeah. So we have some additional resources for you. At Hexabuild, we, believe a lot in, community contributions and sharing our knowledge with the community at large. We've done these IPv6 Buzz podcasts for packetpushers.net. You can get them on your favorite podcasting app. We have almost 60 episodes. We can talk a lot about IPv6 if you haven't realized. We've written a lot of great articles for the Infoblox IPv6 Center of Excellence. I've written a bunch for Network World, many articles on IPv6. So yeah, many of these resources are available. Just Google, Hexabuild, our names, and IPv6, and you'll find a lot of the things that we've contributed out there. We're offering training classes now online with live instructor-led courses. It's us teaching the courses. We do it all virtually using virtual labs and virtual meeting software, just like we're using today. We have some of our more popular classes available. Hexabuild.arlo.co is the website. You can go and check it out. And we have a variety of documents on our website available for download: white papers, solutions briefs, service briefs, the mergers and acquisitions white paper that we mentioned as well. So lots of stuff to download for free. So yeah, we want to have a little bit of time for questions and answers. So please ask us questions and put them in the chat, and we can go through those. Who would like to take the first one, or which question should we answer?
Well, that looks like a Tom question.
Yeah, it's a great question, right? So,
okay. So maybe we can read it out so that way.
Yeah, of course. The questioner is asking about an experience with RIPE, which of course is the European Regional Internet Registry, and asking for IPv6 space, and in particular, provider-independent IPv6 space that can be routable through different providers. Space that enterprise would be using throughout the duration of its existence. So there's a comment here that through the ISP, which is the sponsoring LIR, and RIPE handles things a little bit differently than other internet registries do. So LIRs are basically given the administrative privilege of handing out additional IPv6 address space or allocating additional IPv6 address space. So service providers like an ISP might be considered an LIR. But the questioner is asking about not being able to get more than 3/48 and then having those be non-contiguous, which means, of course, you can't summarize them, even though documenting that there's a 28 in site. So, of course, if you're assigning a /48 per site, you're already to the next nibble boundary there with the /44. So this is a challenge, right? So RIRs, they want to do the right thing in terms of giving you the address space that you need, but they're kind of like the genie that's totally literal and only gives you what you ask for. And the challenge then is looking at the language of the policy and making sure that you're actually able to fall into whatever administrative category is going to meet your need operationally, and then being able to make that case to the RIR. So this is one of those corner cases where because of the language that they're using in the policy, you can get wrapped around the axle saying, well, we don't really want to be an LIR. That doesn't really fit us. So we're just going to go in as just an enterprise, a small enterprise asking for this amount of space. And there, the tweaking of the language can be critical to getting the RIR to do the right thing, which they want to do. They want to make sure that you have enough IPv6 address space to support your operations. So yeah, that's a great question. But as an enterprise, you may not be as familiar with interacting with the Regional Internet Registry, and we can certainly help with that. I mean, that's something that we do over and over again. It's like really helping navigate the administrative channels of the Regional Internet Registry policy language to get you into that sweet spot where you can get the allocation that you need.
Yeah, because with 28 end sites, that would qualify them typically for a /40.
That's right.
Mm-hmm. Yeah. Okay. I'll take the next one. One of my friends from many years ago asks, why is there not an RFC 1918 like NAT for IPv6? Yeah. So unique local addresses is that private address space you can use in your own isolated network, but it's not for use on the internet. And we don't have an RFC NAT66, so we don't do port address translation for IPv6 like we've done in the past for IPv4, where we have NAT44. But what the IETF has created is this protocol called Network Prefix Translation version 6, NPTv6, that exists, which is a one-to-one stateless mapping between internal private addresses and global or internet IPv6 addresses. But sometimes it's not available in the internet edge, product you might be using, your firewall, your internet perimeter device, or your router. There are ways you can. Some vendors have colored outside the lines and built NAT66 into their products, and so it can be configured. They call it NAT66, even though there's no official RFC like that. Really, we recommend that you try to use global addresses for internal systems and external systems. Just use firewall policy that's stateful to prevent the unauthorized inbound connections. But you can use global addresses internally in your network.
And you should.
Yeah, and that's often recommended. And you have plenty of them to go around, and you should not need to do any kind of NAT. And most perimeter devices will be stateful for IPv6, allowing the outbound connections out, from your internal network out to the internet, and keeping state open for the duration of the connection, and then preventing inbound connections as well. So that's what we would recommend, is use global addresses, rely on the statefulness of your security protections at your internet edge.
And it is possible to use also some of the available ADCs or server load balancers or application delivery controllers to do 6 to 6. So if you're used to doing server load balancing inbound using, maybe a V6 to V4 or V4 to V4, right? From a public V4 to a private V4, a VIP to a, real pool or something like that. You can do very similar things with V6 to V6 and basically have two different address spaces on either side. And it will work just fine for doing that. So it is possible to build things that look very similar to what you're doing in V4 today. Just understand what you're building and why.
Okay. Well, we're getting to the end of our show here, and at the time that we had dedicated for this show, we've run out of time for questions. If you have more questions, we'll try and answer them on one of our IPv6 Buzz podcasts. We do listener question shows. So if you have other questions today or in the future, just send them to us, and we'd love to answer them. You can reach us on info@hexabuild.io. If you have any kind of question, we'd love to answer them for you. So please reach out to us if we can ever be of assistance to you and really enable you and your teams to move IPv6 forward. We really appreciate you giving us your time today and listening to us, and we appreciate your questions. So thank you so much for attending the HexaBuild IPv6 webinar, and have a great day.